The biggest strength is that it doesn't explain relativity too early. It lets the viewer feel the problem first, which fits the Feynman-style science content you're building. One small improvement: make the opening physical sensations more concrete: seat pressure, engine vibration, stars shifting, and the strange realization that the same clock inside the ship will not agree with a clock far away. That gives you a stronger cinematic bridge into Section 2 without revealing the answer. The transition question is also excellent because it naturally creates the next curiosity loop. Where does the strange behavior actually begin, and what is changing as you approach the limit? That should make Section 2 feel like a continuation of the same mystery rather than a separate physics lesson. What works especially well? The central mystery is clear. Why can't you just keep accelerating? The wrong explanation elimination is excellent. It prevents viewers from settling on the usual space creates resistance misconception. The progression from propulsion to energy to space/time to light creates a natural escalation. The evidence is already available tease is particularly effective because it makes the answer feel discoverable rather than arbitrary. The transition into Section 3 is excellent because it creates a second curiosity loop. Now the viewer wants to know not only the answer, but why previous explanations are inadequate. One scientific refinement: I would slightly adjust this line. The faster the spacecraft moves relative to an observer, the more energy is required to produce additional increases in velocity. It's correct in spirit, but for maximum scientific precision, avoid implying that an object literally becomes harder to accelerate because its relativistic mass increases. A cleaner framing is, as the spacecraft approaches the speed of light, each additional increase in velocity requires disproportionately more energy, while the speed gain becomes smaller and smaller. That keeps the explanation accurate without prematurely introducing complicated mathematics. Best narrative structure. The section should feel like, it isn't a wall arrow, it isn't failing engines arrow, it isn't cosmic friction arrow. So what is happening? Arrow. The answer involves energy, space, and time arrow, and the evidence is already in ordinary measurements. That gives Section 3 a perfect setup for your anti-influencer credibility firewall. Overall, 9.7 over 10. What's strongest? Start with what different observers measure is the right foundation. It naturally leads toward Einstein's postulates without dumping equations too early. The myth-to-mechanism contrast is compelling. Time stops, and you become infinitely heavy are useful myths to neutralize because they are common shorthand, but your outline correctly avoids presenting them as literal descriptions of what a traveler experiences. The Feynman-inspired philosophy fits perfectly. Make the physics simpler without making it less accurate. The transition to Section 4 creates a nice payoff delay instead of immediately explaining everything. One important scientific refinement I would change: the measurements of time, distance, momentum, and energy transform according to special relativity to something slightly more precise. Different inertial observers can measure different times and distances between events while agreeing on the laws of physics and on the invariant speed of light. Why? Because this keeps the focus on observer-dependent measurements, which is the conceptual heart of special relativity. Also, be careful with mass becomes infinite. You can absolutely present this as the popular claim, but make it explicit that modern relativity generally avoids describing this as an object's relativistic mass becoming infinite. The invariant/rest mass remains unchanged. What grows without bound as v approaches CE is the energy required to continue accelerating a massive object. Narrative progression. Your first 3 sections now form a very strong chain. Section 1. Something strange happens as you accelerate. Down arrow Section 2. Why can't you simply keep accelerating? Down arrow Section 3. Maybe the popular explanation isn't actually the explanation. That is exactly the kind of progression that can make the eventual mechanism feel like a discovery rather than a lecture. Final rating. Concept, 10 out of 10. Scientific framing, 9.7 out of 10. Curiosity architecture, 10 out of 10. Transition, 9.8 out of 10. With the small wording refinement above, I'd consider this 10 out of 10 ready for the full script. What works 150 words is enough for positioning without damaging retention. The CTA reinforces the channel's identity, mechanism over slogans. Respect for the viewer's intelligence is exactly right for this science/Feynman style format. The return to the science is immediate, which keeps the curiosity loop alive. The transition into Section 5 is especially strong because Section 5 can finally start showing the actual physical chain. One improvement: avoid making the CTA sound too much like "this channel explains." That can momentarily remind the viewer they're watching YouTube. Instead, make it feel like a natural statement of philosophy. If you prefer explanations that slow down long enough to show where the strange result actually comes from, this is the kind of physics we explore here. Then immediately return to the spacecraft. Recommended narrative rhythm: credibility to brief invitation to immediate science. Not credibility to subscribe request to channel promotion to science. That distinction matters. Section 4 to Section 5. Your transition is excellent. So now, instead of asking what light speed looks like from the outside, let's follow what actually happens to a massive object as its velocity keeps increasing. It naturally opens the door to the mechanism chain, where you can introduce velocity, kinetic energy, momentum, time dilation, length contraction, and ultimately, the invariant speed limit. Final rating, 9.5/10 Asher, very strong and ready to build on. The mechanism chain is very strong. Invariant C to Lorentz factor, to energy to time, dilation to length, contraction to simultaneity to null trajectories. That is a much better architecture than explaining each relativistic effect as an unrelated, weird thing. The strongest part: the section correctly makes relativity of simultaneity the conceptual centerpiece rather than treating time dilation as the whole story. That gives you a powerful progression. Light speed is invariant, implies space and time cannot remain. Absolute implies Lorentz transformations connect. The measurements implies gamma, quantifies the transformation, implies energy diverges as V approaches. C. That is the actual intellectual payoff. Important scientific refinements. 1. Be careful with energy becomes the barrier. I'd phrase it as the energy required to accelerate a massive object towards C grows without bound. This is more precise than suggesting energy itself is a physical barrier. For a 1,000 kilogram spacecraft, the relativistic kinetic energies are approximately 0.9 C, 1.17 times 10 to the 20 joules, 0.99 C, 6.37 times 10 to the 20 joules, 0.999 C, 6.32 times 10 to the 21 joules, 0.9999 C, 6.36 times 10 to the 22 joules. Those numbers are fantastic trust anchors because they make the asymptotic behavior tangible. 2. Clarify the 0.9 C time example. Your 0.436-year figure is correct as a ratio. 1 over gamma approximately equals 0.436. But say, if one inertial frame assigns 1 year to the coordinate time interval, rather than implying that the traveler literally experiences a universally defined 1 year. 3. Length contraction wording is good. At 0.99 C, L equals L, 0 over 7.09 is approximately 0.141 L0. So roughly 14% is correct. But emphasize that each inertial observer measures the other frame differently. This prevents viewers from imagining a universal physical squeezing of the spacecraft. 4. The photon section is particularly important. Your instruction: avoid saying, from the photon's perspective. Absolutely keep this. A photon has no valid inertial rest frame in special relativity, so saying, what does the photon see, is not technically well defined. The proper time explanation is much stronger. Massive objects follow time-like world lines and can have proper time. Light follows null world lines, for which the space-time interval, and therefore proper time along the null path, is 0. That gives you the scientifically rigorous version of the popular phrase, light doesn't experience time, without anthropomorphizing photons. One structural improvement: I would slightly reorder the final portion. Mechanism 6, relativity of simultaneity down arrow. Mechanism 7, why all of this follows from the Lorentz transformation down arrow. Energy divergence / why massive objects cannot reach C down arrow. Why photons are different. This makes the logic feel less like, here are several weird effects, and more like, these aren't separate effects, they're different faces of the same space-time structure. Your core payoff. The viewer should leave Section 5 understanding one sentence. A massive object doesn't fail to reach light speed because something eventually stops it. Rather, the structure of spacetime makes the energy required to reach CE diverge without bound. That is the central scientific answer your entire video has been building toward. Final score, 9.8/10. With those precision adjustments, this becomes a 10/10 mechanism section. The numerical progression is excellent. 0.9 C to 0.99 C to 0.999 C to 0.9999 C. It makes the asymptotic behavior intuitive without needing heavy mathematics. One important wording change. The body/physical system actually needs, I'd use, what the physics actually requires. The spacecraft itself doesn't have to feel an increasing energy cost in some special local sense. The issue is the energy required in the chosen inertial frame to continue increasing its velocity toward C. Also, this line is excellent. They were taught to imagine speed as a simple number on a dial. Keep it. It gives the viewer permission to abandon ordinary intuition without making them feel foolish. Section 7. 10/10, conceptually. This is arguably the most important section in the entire video because it prevents the classic "time literally stops" misconception. Your 5-step reframe is exactly the right structure. Belief to legitimate origin, to distortion, to precise reality, to intellectual permission. That last step is particularly powerful. You're not saying, everything you've heard is wrong. You're saying, the popular version started with something real, but the shortcut hides the actual physics. That builds trust. One crucial refinement I would be extremely careful with. The traveler experiences their own proper time normally. This is correct, but make the reason explicit. Locally, the traveler always experiences their own proper time normally. Their watch does not appear to them to slow down. The time dilation comparison arises when comparing clocks following different world lines, or when assigning coordinates between relatively moving frames. The photon explanation is excellent. Keep this distinction: null world lines and zero proper time, not a photon having a conventional point of view. That is scientifically much stronger than the typical YouTube phrase. From the photon's perspective, no time passes. You can still mention the popular phrase, but immediately qualify it. 1. Historical precision instead of Einstein's 1905 special relativity paper, the Lorentz transformation, and the modern spacetime formulation associated with Minkowski geometry. I'd present them as 3 layers of development: Einstein's 1905 formulation of special relativity, Lorentz transformations, as the mathematical transformation between inertial frames, Minkowski's later spacetime formulation, which provides the geometric picture that avoids making it sound as though all 3 came from the same source or moment. The combined narrative is now excellent. Sections 1-7 form a very clean intellectual staircase. 1. You accelerate leads to something strange begins. 2. Why can't you keep going? 3. Popular explanations aren't precise enough. 4. Let's follow the mechanism. 5. The mechanism connects C, gamma, energy, time, distance, and simultaneity. 6. 99.9% is almost there, turns out to be a misleading intuition. 7. Time stops turns out to be a misleading shortcut. That leaves Section 8 perfectly positioned to answer the viewer's next natural thought. Okay, but what would the journey actually feel/look like? Final ratings. Rating section 6 9.8/10, Section 7 10/10, combined narrative flow 10/10. With the few wording refinements above, this is publication-level science outline architecture. What works exceptionally well? The 7-stage journey gives the viewer something they can mentally replay: ordinary to relativistic, to 0.9 C to 0.99 C to 0.999 C to approaching C to C. That turns several abstract equations into a single visual trajectory. The strongest line is, light speed is not a finish line that a sufficiently powerful engine could eventually cross. That should absolutely remain. It reframes the entire video in one sentence. The 3-question checklist is excellent. Keep this exactly as the viewer's takeaway. What frame is making the measurement? Are we discussing velocity, energy, or proper time? Is the object massive or massless? This is more useful than simply asking viewers to memorize gamma or a formula. It teaches them how to think about relativity. One scientific refinement I'd slightly modify: it is a boundary separating massive time-like motion from null motion in space-time. 2. It is the invariant speed associated with the boundary between timelike and null world lines in spacetime. Why? Because saying light speed is literally a boundary separating two types of motion can sound as though c is a physical surface. Your version is already conceptually good, but the refined wording makes the geometry clearer. The engineering caveat is important. Your final paragraph is excellent because it prevents viewers from confusing special relativistic possibility with practical spacecraft engineering. I'd add one subtle point. Interstellar dust and even extremely sparse particles become extraordinarily dangerous at relativistic speeds because their collision energies become enormous in the spacecraft frame. That gives the engineering caveat real physical weight, rather than making it sound like generic space is difficult language. Narrative function. Section 8 finally pays back the curiosity debt built since Section 1. The viewer has now learned. Acceleration doesn't encounter a wall. Energy requirements explode. Time and distance depend on the frame. Simultaneity changes. Massive objects remain timelike and cannot reach c. Light follows null trajectories. And then your transition. Now go back to the spacecraft we imagined at the beginning, but this time you know what every fraction of that increasing speed actually means. Is excellent because it creates a circular narrative payoff. Rating. Scientific accuracy, 9.8/10. Viewer comprehension, 10/10. Narrative payoff, 10/10. Retention structure, 9.9/10. Overall, 9.9/10. Essentially ready. The key is that you're not repeating the explanation. You're repeating the image while allowing the viewer's understanding to change. At the beginning, I'm accelerating toward light speed. What happens? At the end, I now understand why the measurements themselves change as I approach that limit. That is genuine intellectual closure. One important refinement I would avoid saying, their understanding of time, distance, simultaneity, and energy has changed. Because technically the viewer's understanding has changed, not the physical quantities themselves. A stronger phrasing would be, the speed on the screen is no longer the whole story. Time, distance, simultaneity, and energy now fit together as parts of one structure. That is more precise and more elegant. The emotional tone is exactly right. Don't make this section cinematic in an exaggerated way. No, the universe reveals its deepest secret. Everything you knew was wrong. Mind-blowing. Your intended quiet intellectual completion is much stronger for this topic. The viewer should feel, oh, that's why, rather than, wow. Transition to Section 10. Your transition is excellent. And once you understand that, the speed of light stops looking like an arbitrary cosmic restriction and starts looking like a clue about what spacetime actually is. That opens the door perfectly for the final conceptual insight. Final rating. Circular payoff. 10/10 scientific precision, 9.7/10 emotional closure, 10/10 transition, 10/10. Overall, 9.8/10. Section 9 is doing exactly what it should, bringing the viewer home without ending the intellectual journey too early. The biggest strength is that you're not trying to summarize the entire video again. Section 9 already provided the emotional and conceptual closure. Section 10 should simply leave one final door open. Best approach. The ending should move. Mechanism to curiosity to next mystery rather than mechanism to like and subscribe to goodbye. I'd also avoid explicitly saying scientific exclusivity in the actual script. The feeling should come from the subject matter, not from telling viewers they are part of an exclusive group. Recommended final direction. End by connecting light speed to a larger question. If you enjoy explanations that go beyond familiar slogans and follow the mechanism all the way through, there are deeper questions waiting. Because once light speed makes sense, space-time itself becomes the next mystery. That gives you a clean continuation into topics like why gravity changes the passage of time, why space-time can curve, why nothing with mass can reach c, what the speed of light really tells us about causality. One important structural note. Your full script now has a very strong circular architecture. Spacecraft to mystery to misconception, to mechanism to intuition breaks, to belief, reframe to mental model, to spacecraft again, to deeper mystery. That is much stronger than simply ending after explaining the speed limit. Final rating, 9.8/10. For this section, less is genuinely more.